All right, so let's talk some critical thinking questions. So first off, in order to calculate this, or this, obviously you would need your density triangle in order to do that. But if you pay attention, it says, okay, you have 3 liquids, you're given the following information, blah, 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 blah. Assume no volume is greater than 100 and no mass is greater than 200. So liquid 1 will stack between 2 and 4. So here's 2, here's 4. So what density, like the video that you guys watched, down below is the highest density, up above is the lower density. So if it's stacking in between, we're thinking of 1.60 grams per ml. Now, what 2 numbers could you put to give you this one? Now, a lot of you will basically plug and chug and guess and check until you get to this answer. You just need to make sure your density ends up at 1.60. So you could do a mass of 1.6 grams divided by a volume of 1 ml. 1.6 divided by 1 is, well, 1.6. This could also be like 16 divided by 10, or basically whatever number you want to kind of like plug in. But this would be the easiest. Like, it still fits. Look, it says assume no volume is greater than 100 mLs. It's not. Assume no mass is greater than 200. It's not. It fits the criteria. Now this is going to be a really, really, really thin layer. Okay, like this one is 65 mLs thick. This one is 87 mLs thick. This would only be 1 ml thick, but again, it'd be really, really small. All right, so you have an object and you double the volume but not the mass. Basically, the mass stays the same. What's going to happen to the density of the object? Prove it with numbers. So look, let's just say the mass was 1 gram. It's 1 ml. Let's keep it super simple. Density is 1 gram per ml. Let's just say the mass stays the same. You double the volume. 1 divided by 2 is half. Okay, so the density decreases, okay, if you double the volume but not the mass. Does this mean all objects will float? Because this is another great question. In this case, yes, but not in all cases. What happens if you had 100 grams divided by 1 ml? Okay, that's going to give me a density of 100 grams per ml. This will sink. What happens if it's 100 grams over 2 mLs? Well, that will be 50 grams per ml. This will also sink. So again, doubling the volume doesn't guarantee that the object is going to float. In some cases it will, but not in all cases. So this one is a soda can one. Basically, so volume, you can find 2 ways. You could read the can. That's the easiest one. Okay, if you want to. Or you can use a graduated cylinder. That's also fine. What about the mass? Well, there's a couple ways to do this. You have a full can. Okay, so with soda and the aluminum minus the weight of just the can. So this is just can equals mass of soda. So this is soda mass. Now, some of you said, okay, well, what happens if you measure the weight of a beaker, pour the soda into the beaker, take this minus the empty beaker? Basically the same thing. All right, someone sells you a silver coin, okay, or sells your relative a silver coin. How do you know if it's real? Well, on the internet, you will find that the density of silver is equal to 10.49 grams per ml. You just need to make sure that this equals that. And then it's likely that you have pure silver. So mass, okay, how are you going to get that? Scale, easy. Volume, how are you going to get that? Easy. So water, I'm not going to write out the full thing, water displacement. Just dunk it in water, see how much water moves out of the way. Then you just take your mass divided by your volume, check to see if it equals that. Done. Okay, so those are your critical thinking questions. I know for some of you it took longer than that, but I've thought through these a lot, so it's easier for me to get through. All right, working over at the back though. So on this one, again, pay attention to what I'm asking for, and you're going to want to round to the second decimal here. So looking at this first one, again, pay attention. What are they giving you? Grams, centimeters cubed. So they're giving you mass. How do I know? Grams. volume. How do I know? cm cubed. This is mass over volume. It's going to give you the density. Find that density, plug it in there. All right, what about the next one? Look, I'm looking at grams. I'm looking at cm cubed, so they're giving me this. They're giving me this. So 39.94 divided by 22.70. 39.94 divided by 22.70 is going to give me something in grams per cm cubed, like that. All right, what about this one? So this one again gives me grams. This one gives me mLs. So that means that I'm looking for density. So 30.94 divided by 35. So 30.94 divided by 35. If I were to ask you really quickly, is this going to sink or float? That number is lower than this one. This is going to sink in water. Or sorry, it's going to float in water, ml. And this will give you something in grams per ml, like that. Okay. Now this one, so I'm not going to do the work for this one, but look, this one gives you density. So this one gives you grams per cm cubed. And then this one gives you a volume, cm cubed. In this problem, which I'll let you solve, you are looking for mass. So just be careful with this one. All right, moving on to the other side. So these are conversion problems. So like you need to convert liters over to mLs. Like I know it's 3 steps over. So it's like 1, 2, 3. That gives you 12 mLs. Okay. So on this one, you have density. You have volume. So look, if I have density and volume, that means I'm looking for mass. I cover up the mass. So it's density times volume. So this is 24 grams per ml times 12 mLs is going to give me my mass right there. All right, so same thing with these. Again, you're going to have to do conversions. Okay, so from 1,000 liters to milliliters, this is going to be a huge number. Okay, it's going to be a huge number. Actually, I'm going to go ahead and cross that off because it's kind of a big number. So let's cross that off. All right, what about this one? This one's looking for density. You have to change this over to milliliters. You have to change this over to grams. Use your step chart. All right, over here, same thing. Look, this is giving it in liters. So you have to change this into mLs. Okay, this is fine because this is already given in grams per ml. So let's put that in. So 0.789 grams per ml. So this, when you convert it over to mLs, you move it 3 spaces, 1, 2, 3, and this is actually equal to 200 mLs, like that. And then you just solve, oops, sorry, this is the wrong spot, 200 mLs, and you solve for the number of grams. All right, what about this one? Rectangular block, blah, 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 blah. So this needs to get converted over into grams. This is a volume problem, so this is length times width times height, and that will give you blank cm cubed, which will go here, cm cubed. Okay, this one, again, it's moving over 3 spaces, 1, 2, 3, that's 1,896 grams, and then it's just this divided by the volume gives you the density. All right, last one I'm going to let you solve by yourself. I will tell you that this needs to get turned into grams. This is already density, so grams per cm cubed. Nothing to do there other than find the mass. And that's it.